Hello and welcome to another video by Flash Jazz Cat, and in this video I present to you the world's first SAVO XEGS system. So this Atari XEGS was sent in from the United States. It was sent with all the upgrades that the owner wanted to put inside the machine, all of which are fitted now. So we've got VBXE, we've got Ultimate 1 MB, we've also got a TK-II XEGS keyboard adapter for a PS2 keyboard, which I'll show you later on. We've got a SAVO XE board, which was, well, ostensibly sent to bring out the RGB video from the VBXE. Now, of course, SAVO is a fairly simple printed circuit board, otherwise known as a PCB, and this is a perfect segue into the sponsor for this video. And the sponsor for this video is, of course, PCBWay, who have been experts in the field of PCB prototyping and manufacture for over 9 years now, and they've been kind enough to sponsor this channel for over 1 year. And not only do they have a lovely front end where you can upload your project files and get an instant quote, but they offer additional services such as CNC machining, 3D printing, sheet metal fabrication, and even injection molding. Now they also have a community area. You won't find the SAVO board here, but you will find the Video Board XE Atari 800 adapter by Candlo Sin. So if you click the affiliate link in the description below the video, you'll get a discount off your first order, and in so doing you will support this channel, for which many thanks indeed. I've never fitted a SAVO board before, although I've had a couple of free samples that were sent in, presumably so I could kind of review them. So I'm going to go ahead and basically do that now. I've got another machine as well, which I'll show you later on. But the SAVO was designed for the XE range and the XL range. This is the XL version out of the other machine, which is an 800 XL. But there currently isn't a version for the XEGS. So I had to modify this board so it would fit in here. And now normally what I would do when I'm bringing RGB video out from VBXE is I'd fit a DIN 13 connector on the back of the board. If you've watched any of my videos before, you'll know I do it that way, and I've been doing it for years. And I use a cable like this. This is one actually made, and it carries stereo audio and the RGB signal, and it's got a SCART connector on the other end. Now the SAVO itself actually ships with a Sega Saturn SCART cable, which is a 10-pin affair, as you can see here. So that gives you a couple of extra pins. This is actually 8-core cable, so you've got RGB control to put the SCART cable into RGB mode. You've got stereo audio, so there's 6. You've got composite, and you've got ground, so there's your 8 connections. Now this one here, I'm assuming that the shield must double as the ground. So with this one being a 10-pin connector, we've also got 2 extra pins for Chroma and Luma video. So that kind of becomes important with the XEGS, of course, because all we've got in the back here is composite and audio. So commonly what I've done before is I've put a 5-pin DIN connector on the back for the legacy video output. So I'd end up with 2 holes here, I'd end up with 1. You can see this doesn't line up very well, but I'll go into that in a minute. You'd end up with 2 holes, one for the DIN 13 for the RGB and another one for the 5-pin DIN for the legacy video out. So anyway, the owner wanted to put a SAVO in there, and it definitely represented a time saver for me because I didn't have to drill a hole in the back. I didn't have to drill holes to put DIN connectors in the board. So yeah, on the face of it, it seemed like a really good way to go. So the owner sent this SAVO XE board. So what's kind of interesting about this arrangement here, we've got 11 pins here, and this is a 10-pin connector, and the ground pin, there isn't a dedicated ground wire inside the cable. This is a Sega Saturn cable, of course. The ground is connected to the shield, but not to the shield on the SCART. So obviously the ground pin here goes straight to the shield on the connector, but it goes to the ground pin on the SCART. The shield on the SCART itself, the actual casing here, isn't connected to anything at all, and that concerned me immediately, because normally, if we take a connector like this one here, the ground pin, which is at the bottom here, goes to the ground pin on the, well, it goes to all the ground pins on the SCART cable. Actually, there's several, because there's a ground for each of the RGB lines, the audio, etc. But it's all tied together because there's only one ground point on the connector at the Atari end, which is the bottom pin here. So they're all tied together, but that's separate from the shield, and the two shields are connected together, but they're not connected to the ground. They become connected to ground at the Atari end and probably at the TV end as well, but they're completely isolated. And of course this cable has a lot of screening wire. It's got shield, quite a thick shield running the entire length of the wire, and that is of course what connects these 2 points through the shield. Now the only SAVO cable I'm actually able to get into at the SCART end is this one, which is actually the one that was sent with this machine. So we can see inside the cable there's the shield area here, which would normally be connected to the shielding that runs around the entire wire loom in the cable. Isn't connected to anything at all. Other peculiar things about this, we've got some electrolytic capacitors on each of the RGB lines here, which I'm assuming is for some sort of AC filter or some sort of thing like that. Obviously we've got all the grounds tied together in the normal fashion. So the purple wire is obviously the ground wire, and that's connected to the shield at the other end of the connector. And here we've got the RGB control pin here, and that's quite interesting because that is connected to the 12 volt line by a 75 ohm resistor. So normally when I make the SCART cables for VBXE, RGB control comes from VBXE and it goes straight here, but on this version it goes to the blanking pin, and then it goes to RGB control via that resistor there. So it's a little bit unusual, and I can't see any kind of screening or shielding or anything at all coming out the end of this cable. Obviously I can't get into the other end here, but it's sort of an unusual looking cable. So I sort of reserved judgment on it before I actually tried it out. Now of course the problem with the XEGS is that the RF modulator is absolutely tiny. It's the smallest one of the lot, and it's a lot shorter than the SAVO XE. Now in fairness, the designer of SAVO, Piotr D. Kazarowski, yes, well, Peter, he pointed out at the weekend when he was doing some experiments with his cables, SAVO XE doesn't fit the XEGS, and that he is going to produce an XEGS compatible version at some point. Now what concerns me a little bit, I haven't fitted an XE SAVO in the machine it was intended to go in yet, so a 65 XE or 130 XE. But we've got these mount points here, so he supplies 2mm pitch header pins, which you'll solder into these little holes here, and obviously the other ends go into the lugs that have been vacated when you removed the modulator. But there's none at the back here. Now it seems to me that this thin board, it's going to flap about something rotten. Now the reason I think that there's no strain relief, because there is a lug on the XE modulator at the back here, but I think what we're going to find is that it's directly underneath where the connector is here. So that's a bit of a problem even with the design as is, because it's going to be elevated above the board. From the middle here, but at the back this is going to flex because there's nothing between the motherboard and here. It's going to flex a bit when you plug the connector in, so that's not ideal. But of course, since there's currently no XEGS version of the SAVO board, what I actually had to do was modify it to fit. So I took off this pin header array here, and there's the rain coming. We hear distant rumbles of thunder, so if the power goes out, Well, we'll have to cross that bridge when we come to it. So what I did basically was, fortunately the alignment of the connector at the back's pretty much the same. But as you can see, there's that little hole there where the strain relief at the back would be, and that was completely off because the hole there is, as I said, right underneath the connector. So that's the reason that the XE board doesn't have any kind of strain relief there. Of course, what I've done is I've drilled a new hole right there in the motherboard, and I haven't finished soldering these things, by the way. They're just sort of tacked in at the moment until I established that the height was correct. But I drilled a new hole in the motherboard, and a corresponding hole here at the back through the board. So there we've got some strain relief at the back there, and that was vitally important because I've lost the strain relief at the back, because that's where all the pin array connectors are. So basically what I did is I took this row of pins off the board, I cut the board, because all this here is just ground, the whole lot just infilled copper. So I chopped it right behind that row of pins, soldered in a straight row of pins. Obviously that's what these connectors are pushed into here, and added this little extra hole at the front, and the thing fits perfectly. When he does the XEGS version, it's very difficult to see, but you can see there's holes there for the actual signals. Well, they're not going to be any good for strain relief. So if we didn't have this strain relief, this support, this standoff at the back here, the thing would just be connected via the two side ones. It would be totally useless. It would be rocking around all over the place. At least on the XE as designed, it's moored at the back, so all you're going to get is flexing at the far back end there. But as I say, that's still not ideal. Really, it needs something underneath there which will line up with this lug, which is exactly in the same place as it is on the other XE machine. So that's a bit of a problem. Obviously I've overcome it here, but that's how I got the thing to fit anyway, and it works. We'll come back to SAVO later on anyway. Now the other thing I had to do here at the behest of the owner is a modification. So here's the TK-II XEGS keyboard adapter. Now one of the problems with the external keyboard on the XEGS that always put me off, because I had visions when I first learned about that machine, oh, wouldn't it be great if I could sit back in the chair, you know, do a bit of word processing there with the keyboard on my lap. Well, the wire isn't long enough to do that anyway. But the other problem is that the only console key that's actually on the XEGS keyboard itself is the help key. Start, select, option, reset aren't present on the external keyboard. Now this becomes a really big problem when you've got a PS2 keyboard plugged in, but fortunately there's a modification, because some of the pins on the XEGS keyboard connector are completely redundant. They're actually doubled up. There's a doubled up 5-volt pin, there's one or two ground pins that are just tied to this infilled ground layer here. So the modification involves cutting away. I'll flash up on the screen. God, I think we've got hailstones at the window or something. It's really freaky weather. It's obviously caused by mental health. I mean climate change or racism? I don't know. It's a terrible world we live in today. But anyway, as you can see by the pictures on the screen that I'll show you on Michael's webpage, you just need to sever and detach, isolate, so to speak, these redundant pins. And he's put the console key, the emulated console keys from the PS2 keyboard, so that's like F8, I think it is, for reset. And he's got a connection going straight to reset here, and 3 more connections that go all the way along the board and go to the console key resistors here. You can see there's another wire there. That one is because I ripped a trace off when I was taking this keyboard connector off the board. Very difficult to get that one off for some reason anyway. There was just one little pin that was hanging on, and I didn't get it quite loosened up, so this trace just pulled up on the top side of the board. But I've used some magnet wire to fix that, so that's no problem. So that works anyway. So I've tested it with the PS2 keyboard, but the problem with this modification, well, sort of a problem, is that a stock XEGS keyboard will no longer work on this machine unless you do a little modification to the keyboard itself. I'm assuming that's because, say, the 5 volts is going through one of the isolated pins or whatnot. I don't know. So anyway, I've put the PokeyMAX in the machine. You may wonder why it wasn't there in the first place. That'll all become clear in a minute. And I'll turn the machine on and you can see it in action. So we've booted into Sparta-DOS X there, all well and good. Now I think the help key on the PS2 keyboard is that one, and that's reset. So there we go into the firmware menu. The firmware is a little bit old, but that must be what's being provided on FGC firmware boards at the moment. The first problem I identified here is if I hold down the arrow keys, you can see it's a little bit on the stuttery side, and also it's not quite so apparent now, but I was occasionally get a double keystroke. But anyway, so there's something wrong with the auto repeat here, which is a bit strange. So I'll boot back into the operating system and we can see if that's a problem confined to the setup menu or if it's something else. So we've got a big problem with the auto repeat on the keyboard. It sort of stutters and it stops and then it starts again. I'm just holding down a key here and it's very, very intermittent, the auto repeat here. Now when I ran into this problem, it sort of it rang a bell, and I was sure I'd seen something written about it on the Atari Age forums or what have you, and sure enough I was right. And there's actually a compatibility issue between the TK-II adapter for the XEGS and PokeyMAX. And I asked Mark, who you'll know as Foft, who was behind the PokeyMAX design. Very nice bloke. I've talked to him a lot when I was adding firmware support for PokeyMAX and the Ultimate 1MB firmware. Great stuff. It's a fantastic piece of kit. But I asked him if this problem that was discussed about 3 years ago on the forum, I'll link it or screenshot the posts, if there was ever any solution found for this, and it appears there wasn't. And Mark suggests that actually it might actually be a problem with the TK-II itself. I've tagged my tech in the reply that I wrote there. Whether anything will be said about it, I don't know. So that's the reason I discussed this problem with the machine's owner, because I think this is terrible. If you'd be trying to cursor around the screen, in my view, that's not usable at all. It's just not usable. It's not just a glitch or a little bit of a quirk with the auto. That's just awful, unusable. So the owner said, anyway, well, we'll just take the PokeyMAX back out. Of course, the way that I've installed it, it's a 2-minute job to actually swap the Pokey in and put the PokeyMAX back, because they're all push-fit connectors. So I just added a mono input to the SAVO board, and if we add the mono jumper, which just shorts the two audio channels together on the back of the connector, then we have a functioning machine. So I'll compare and contrast this. I'll take the PokeyMAX out. So all we've got to do here is pull this connector out here, pull the PokeyMAX board out, put the Pokey back in, and up here we've got the mono jumper, which we're going to push on here. We're going to take the stereo out and we're going to put the mono input back in, and that's it. So that's the PokeyMAX removed, Pokey reinstalled. Okay, so now we have perfectly functional auto repeat on the keyboard, no problems whatsoever. Of course, we've got this computer connected via the SAVO Sega Saturn SCART cable, and the quality is surprisingly good given that there isn't any shielding on the cable. I say it's reasonably good. There's a little bit of a ghost effect here, which doesn't really show up on the camera, and I would put that down to the complete lack of screening on the cable. But it's not bad, but it could be a lot better, so your mileage may vary there. I'd prefer to see a properly screened cable, and I don't think you're going to get around that. But this is what the customer sent in. There was actually a little bit of confusion as to how a US customer is going to get RGB, or specifically the VBXE display out of the machine. Well, it's via SCART, so you're going to need some sort of upscaler, usually if you're in North America, because of course they don't have SCART TVs in North America. We don't even have them in this country now, but of course usually in Europe you can source an older TV with a SCART RGB input. But I did notice that on social media at the weekend, the designer of the SAVO was trying all sorts of solutions to improve the video output using his SAVO adapter and the SCART cable that's provided with it. And I was a little bit worried that he was basically fighting against the inherent shortcomings of the cable, and I still think that's probably the case. Apparently there's a pro version that you can buy that comes with a better cable, but the thing is, SAVO is already, I'll flash up on the screen the vendor web page. Now the SAVO device is on sale at Retro Lemon for £25.95, I think it is, and that does include shipping. But the problem I can say here, certainly from, let's say, my point of view, if I hadn't already equipped all of my RGB capable Atari 8-bits with DIN 13 connectors, and I'm perfectly happy now to make custom cables for them. So let's say I wanted to equip a load of machines here with SAVO boards. I don't need a SCART cable for each machine. I only need one cable, because the cable is going to be left plugged into the back of the TV, and the computers are going to alternately connect to the connector that's on the desk. I don't need a cable for each one. Now, I looked up the price of Sega Saturn SCART cables online. It seems to me that you can buy them for about £5. And bearing in mind, I'm not trying to shit on the project here deliberately. I'm just trying to rationally figure out the kind of logistics and the value for money. This is a very, very simple board. It's very thin. It's a 2-layer board. Basically, it's got a few traces on it. One connector. I think the connector is probably worth a couple of pounds if you buy them in bulk. And a row of pins. And the cable can be had for about £5, the basic cable. So it's quite expensive to buy it with the cable, it seems to me. And if you wanted to buy 3 SAVOs to put in your computers, you don't really need 3 cables. So I don't know if the option exists to buy just the board on its own, and if it did, I'd be very interested to see what they would sell this for. So for comparison, this is this cable here, which I use for the DIN 13 equipped machines. This is made from what's described on by the vendor as defense quality screened 8-core cable. It's decent cable. The screening on it is extremely thick, and as I explained earlier in the video, one end of the screening is connected to the shield on the connector, and the other end's connected to the shield here. It does a reasonable job, but this is the latest cable I've made. I've been experimenting with various grades of screened cable to find out which one actually works the best. So we've got ghosting on the screen a little bit. The cable isn't the best, and it's all very well saying that you can buy a pro version that's got a better SCART cable. Well, that's going to be even more expensive than £25. How much is the pro version going to cost? £30, £35? And once again, you're constantly ingesting spare cables that you don't actually need, because you only need one cable if you've got a collection of computers that all use the same connector on the back. But anyway, right, so this is what I'm talking about here. It's very, very difficult to see. We'll see if we can get a display that shows it a little bit better. It's not really apparent in the firmware menu. I'm wondering if it might actually be apparent in the self-test, so we'll try that. Yeah, it is apparent here, so we get a much better look at this bleed and ghosting effect here. It's actually quite bad. So we've got the S there, so we've got nice contrasting colours here, and we've got another sort of ghost of the S in a lighter hue there, and then we've got a dark one there. So I'm not well placed to actually theorise on why this is, but this, I think it's the cable. It's not really doing a very good job of keeping out external interference. So we've got this kind of bleed over here. That's what I'm assuming it is anyway, I don't know. So this is a SCART cable I made using exactly the same kind of screened cable that's used with the 1088 XEL cable from Cool Novelties. obviously we're using this is a 600 XL with a DIN 13 connector on the back. Now we've got these slight vertical, like sort of ghostly vertical lines here, which I assume is something to do with RAM refresh. Be interesting to see if that went away if I put an SRAM board in the machine, but I haven't got that deep into it yet. So this isn't perfect, but what we don't have here is the ghosting effect that we get on the SAVO cable. That's just not there. I'll go into the self-test, which was a better indicator here. So what we have got here, we've got these slightly more pronounced lines at the left, but what we don't have here is this ghostly repetition of the S character. Right, so this is an 800 XL into which I recently fitted the XL SAVO board that I was showing you earlier on. So we're using the same cable here, and if we go for a close-up, again it's very difficult to see, but we've got a very slight ghosting effect. The vertical banding is it's there, but it's different to the cable I made. It's not quite as pronounced actually, so something in the SAVO cable is doing a good job of minimizing the vertical stripes that we get here. But again, if we go to the self-test and we'll have a look, again we've got exactly the same ghosty type of effect there at the bottom. Different computer, same cable. So I've swapped the SAVO cable for a different SAVO cable, but this one's a little bit more difficult to push in the back. Now, interestingly enough, with this different SAVO cable, if we go for a close-up here, that ghost effect doesn't seem to be as bad. So I think we've got some variance in the cables as well. I can't get into this cable, so I can't tell you what's inside of it. It's completely impregnable, unfortunately, but this cable is better than the other SAVO cable. It's clearly there's some variation in the quality of these SAVO cables, and if you get a good one, it can look pretty good, but if you get a bad one, you're going to end up with that sort of ghost effect by the looks of it. Now, another of the problems we've got here, the whole point of SAVO is that you don't have to drill a hole in the back of the machine or widen this hole as what I do. Attach a DIN 13 connector directly to the motherboard there after I've took the RF modulator off, and I have to widen this hole. It's actually off center as well, so it's a bit tricky, but the result is that you get a hole the same size as the legacy monitor jack over there, with the same size connector, and of course that's what I plug the DIN 13 connector into. Now the idea here, the whole point of SAVO is that you don't have to do that. You take the modulator off the board, fit the SAVO board in its place, and then you plug this connector in like this. Now the problem is the shroud on the connector, I think they have to actually cut it back to make this work at all. So I think it's had about 2mm trimmed off the plastic part here, just so that it will reach the connector and the board there. So you can see there's not much of the connector actually going in. The reason this is rattling about, by the way, is because I've only lightly soldered it in. So the existing hole in the back of the machine where the RF modulator used to be is not wide enough for the barrel of the connector to go through. It's just this metal part that will reach through there. So when you get to the plastic part, it stops. Now the problem is that this often isn't sufficient for it to actually come on. If I turn the machine on here, we've actually got no picture until such time as I plug it in a bit harder, and then we've got a picture. As far as the alignment's concerned, the alignment's absolutely spot on this machine, on the 800 XL. It's in exactly the right place. The problem is this distance from the back of the connector to the actual outside of the case. That's what makes it a little bit hit and miss as to whether the pins are going to go in far enough into the connector to actually make contact at all. So that's a bit of a problem. But we've got another problem as well when it comes to the XEGS, which I'll show you. This isn't really a problem with the design. When I installed the modified SAVO XE in the XEGS, I hadn't read the manual, and the manual does specifically point out that the XE flavour of the SAVO board needs to be mounted lower more or less flush with the motherboard. And there is an insulation layer, a plastic sheet provided, which you can put directly underneath the SAVO board to stop anything shorting out on the motherboard underneath. Right, since I just wasn't happy with the alignment of that connector before, what I've done is I've taken this little plastic standoffs off the pins underneath the SAVO board, and I've put the insulation plastic under the SAVO board that was supplied with it, trimmed it down to length. And since this is now mounted a lot lower, it actually lines up. I would still have needed to open that hole up, as I have done, for the connector to reach the pins inside the connector. So that's actually turned out quite nicely, because the plastic shroud fits in to the hole. Trying to do it with the existing hole without changing it, it's a little bit hit and miss. But hopefully the XEGS version of this SAVO device will somehow throw the connector much closer to the back of the case, which will probably solve the problem completely. But I mean, that looks almost as if it was designed to be like that. It's functionally ideal, but still got to drill that hole out. So that's a bit of a problem, because the SAVO is sold as a device that requires no external modifications whatsoever to the case, and it's a good idea, but in its execution you have the problem of not being able to plug the connector in far enough that it's going to make firm contact in the socket, and the XEGS has got the issue of the lack of a standoff at the back. And then on top of that, of course, we've got the variation in the cables. I'll give the customer, I think this was one of my cables, but I'll give him this one because it's much better quality than the other cable that I was able to take apart. What I'm tempted to try with the cables that I make, with the DIN connectors on the back, is try these electrolytic filter caps in the SCART connector itself. I might give that a try and see if it helps with the jail bar problem. So that the cable type that I was able to dismantle obviously isn't very good, but this one is. So hopefully these are the ones you'll get with the production SAVO. So is SAVO something I would use in my own collection of machines? Well, it's not, for the reasons that I've mentioned before. I'm not aware of a means of purchasing these boards without the cables. It's a little bit, I mean, if you buy 3 SAVOs, you're talking about 75 quid, and you have 2 redundant cables of indeterminate quality, I have to say. And it's not the kind of magic solution that I think it was intended to be, for the reasons I've mentioned. Firstly, the problem of the connector not fully being pushed home once it's actually in the machine. The problem of support at the back of the XE board, which is a difficult issue. I don't quite know how that could be addressed. And we've got the issue of cable quality variance. So it's when it's good, it's better than I thought it would be. I was mainly concerned about the quality. As far as the practicalities are concerned, it's definitely a big time saver. The other machine wasn't sent in with the SAVO board, but I suggested it to the owner. But as far as not having to drill the back of the case out and make a mess with dust and plastic bits all over the place, I'm all for that. That certainly saves me time and effort, and aesthetically it looks good. But I just don't think that the objective that this set out to achieve is actually possible, because you're always going to have some sort of compromise in terms of the rigidity of the connector, the accessibility of the connector, and the quality of the video, unless you go for, as I say, the supposedly a pro version, which has a higher quality screened cable. So there you have it anyway. That's a nice XEGS system with a lot of upgrades in it. It's unfortunate that we had to take the PokeyMAX out just so that the keyboard would work properly. But yes, so this is the first Atari XEGS in the whole world that's got a SAVO board in it, as far as I can tell. So yeah, that's pretty much it. So anyway, thank you very much to the patrons as always. They get early access to the video before the YouTube ads are enabled. Your support's very much appreciated. So if you enjoyed the video, of course a like would be appreciated, as would any comments below. Thank you very much for watching. I will see you in the next video, so bye bye for now.